homework answers from last night. So several people are feeling like they didn't get it, so we're going to get it right now. We just finished talking about number 1. It's linear, mx plus b. We know it's a decreasing line. No work needed. Linear functions do not have a restriction. Number 2 says g of x equals okay, good job. What kind of function is this?
It's a quadratic function.
Quadratic. The reason that people are saying it's quadratic, what's the highest power you see here?
2.
2. As soon as I see that 2, I know it's quadratic. Again, no work needed. Last year, if you were asked, does this open up or down, you would have said positive a value opens up. I'm not requiring the sketches, but I strongly want you to see connections to last year. This opens up all real numbers. Again, no work. No work. Because linear functions and quadratic functions yesterday, we learned have no restrictions. And by the graph, I can see I come in from the left, negative infinity. I come in from the right, positive infinity. Number 3. What's number 3 say? Like this? So for people taking notes right now, if I wrote linear, I want to see linear on your paper. If I wrote quadratic, I want to see quadratic on your paper. If I drew a sketch, you draw a sketch. That's what makes these good notes. So go ahead and call that linear. Write mx plus b, draw the line. So for number 3, did I write number 3 right? Check your papers. What part of this do I choose to pay attention to? Just the inside. So take a highlighter. If you don't have a highlighter, raise your hand. Somebody's going to bring that bucket to you. If I highlight, you highlight. Ayana, pass him the orange one behind you, next to you. I'm going to choose. I'm going to make a choice to only pay attention to x minus 8. What do I do with x minus 8? I'm going to give people a chance to get a highlighter. We're going to take x minus 8. We choose to set this what? What inequality are we going to set up? Greater than or equal to? 0. Good question. The question is, why don't we add the 14? Is this 14 underneath the radical sign? No. So we only take what's underneath the radical. And when I solve this, how do I solve this? You do know. How do I get x by itself? Nope. Nope. No. Thank you. Add 8 to both sides. You got help on that one, so let me ask you one more question so you can answer it yourself. What inequality do I get when I do that? X is what? Let him do it. Shh, no shouting out. What do I get? That is 8. Try again. What inequality do I still have? Very good. That's exactly what I need for my answer. So watch. My answer, all real numbers, x greater than or equal to 8, and I'm done. I'm done. This 5 doesn't matter, and this 14 does not matter for the domain. We just pay attention to what's underneath the radical. Number 4. What does number 4 say?
Y equals 6x squared plus 3x minus 11, all the numbers.
Y equals, say it again?
Y equals 6x squared plus 3x minus 11.
Who's got this one?
Me.
Louis?
Yeah. Oh. It's a quadratic function.
Quadratic, how do you know?
Because of the 2. It's the highest power.
Highest power right there is 2. Very good. So my answer? I want to put that in blue. Just making it.
And it goes up.
It would open up. All real numbers, no work required. Yes. Quadratic is the name of the function. So if I ask you for the name, that's the answer. If I ask you for the domain is all real numbers. Yes. So we know it goes up. Good question. From last year, if I have a positive a value, this is a positive 6, it opens up. If this is a negative 6, it would open down. Everybody try number 5 on your own. Try number 5 right now. So Question number 5. Go for it. What do I do? What inequality am I going to choose to set up? You think about it by yourself. I want everybody to have their own moment of success right now. What inequality do I choose to set up? Check in with a neighbor. Good question. So the question was, if it's a negative x, do I need to flip the sign? It's not that you have a negative x, it's that you have what in front of x? Negative 1. So that negative represents a negative 1 times x. So to get x truly by itself, what do I then need to divide by? To get rid of that negative sign, which really represents a negative 1, we have to choose to divide by that negative 1. And dividing by a negative number is what will switch the inequality sign. Yes? Hold on, let me see what 6 says.
P of x equals odd root 2 and odd root 2x.
P of x equals the third root.
The 2x plus odd minus x.
Okay. What do we know about this?
All real numbers is an odd root.
Yes. So if you have a second color, like I'm not going to use blue because we've been using blue to highlight underneath the roots. What kind of root is that? It's cubed. It's an odd root. Odd roots. From yesterday's discovery, do odd roots have restrictions?
No.
No. Jeffrey? Correct. Odd root. No work required. No work. Because, again, I don't expect you to have the graph as part of your answer, but to show you, the graph is going to look something like that if you put that into a graphing calculator. When you come in from the left, negative infinity. Come in from the right, positive infinity. No restriction on odd roots. All odd roots look something like that. Number 7. Try number 7 on your own.
Wait, how does that look like?
That's an odd root. Everybody's doing number 7 on your own. Let's have success here. Yeah. What kind of root is this? What invisible number? What do you call that symbol? If I ask you what that symbol is called. This right here. This thing.
Square root.
Square root. You notice how you said square? Square is associated with what number? Okay, when you square, there you go, a 2. So this whole time, there's always been an invisible little 2. So that makes this an even root. An even root. So what am I going to highlight? Just what? Just that. And what are you going to do with that?
Do the same thing?
Yeah. This is always what we're going to do. Go for it. Try it. So I have f of x equals negative 1/2. Yes. Negative 1/2 square root. What are we thinking about this? And why? What kind of root is this? Because we have even roots and we have odd roots. How do you know it's even?
Because of the 2.
The half has nothing to do with it.
Because of the 2 on the outside.
Right. Look at the screen. Remember, you have been drawing this symbol for the longest time, and you say square root. What number is associated with that word square? 2. This whole time, there's always been an invisible little 2 right there. It's just never written. So now that we have actually written in the little 2 that has always been there, just never written, what kind of root is that? Even. Even root. Even root. So what are we gonna highlight? Just the inside. The 1/2 doesn't matter. The 2 doesn't matter. So, Dave, let me say again. This symbol that you've been drawing forever, look, has always had a little 2 right here. It's just never actually written like that. Just like x is technically x to the first, but nobody ever puts the 1. There's always been a 2 right there. It's just never written. So that's how you know a square root is even. Yeah, this negative 1/2 and this 2 would affect the shape of the graph, but have nothing to do with the domain. So what inequality am I going to set up? 3x plus 15 greater than or equal to 0 and solve. I'm going to move where I wrote that. You guys solve that, please. Set up your inequality. 3x plus 15. Put it in a different color even. 3x plus 15 greater than or equal to 0. This is a choice we make. We are choosing to do that. So I'm going to subtract 15. Yes, Shamar? When you say negative 5, that's part of the answer, but it is not the answer. 3?
Negative 3. And then you divide by 3, and then you get x equals
X is greater than or equal to
5.
negative 5. And then how do I translate that into an answer?
All the numbers. X is greater than or equal to negative 5.
No. Look, this one's not. We've done like 3 or 4 that are not, that have a restriction. Any even root is going to have a restriction. Fantastic. Fantastic. And then how about, do we have one more? What's number 8 say? People are saying it. What's number 8?
Linear function.
8 is a linear function because the highest power of x there is what?
It's 8. Negative 8. Wait, what?
What power is right here, just not written? 1. So that is why we know for a fact this falls into mx plus b. What would be the y-intercept of that graph? 0 would be my y-intercept. That's the invisible b. All real numbers. So people who came in on shaky ground on this, I need to hear from you either through remind or stop by at the beginning of the day, because today I did change my plans. We're possibly only going to get to start what I finished with your classmates in other sections. You have to reach out to me. I was after school till 4 o'clock yesterday. I am always here for you, but I can't help if you don't reach out. So contact me. If you need the remind information, you let me know. So keep this firmly in your mind, what we just talked about, because we're going to do our second discovery. These functions look super cool. Different. New kind of function we're going to talk about. What are these functions called? For people who have the handout, what are these called? What are these functions called? Starts with an R. So this is a good example of why we are not finishing. Hold on. Excuse me. Thank you. Did anybody hear the question I asked a minute ago? What was the question? Jeffrey. What are we doing? What are these called? Thank you. So let's all settle in. Let's get our minds on this right now, okay? Rational functions. Highlight that word. All that means is x is in the denominator.
What?
We're going to look at them right now. This is a brand new kind of function. You've never looked at these in Algebra 1. This is officially Algebra 2 right here. Now, each of these functions right here, this is their graph. So we're going to take our highlighter and we're going to first identify what is this graph avoiding. We're not going to look horizontally. We're just going to look vertically. It means up and down. So if I asked you here, what vertical line is this graph avoiding? What would you say? The y-axis. So let's highlight the y-axis. Carefully highlight just that y-axis. And now let's look at B. What x value is this graph avoiding? What vertical line? Still the y-axis? No, the graph goes through the y-axis. True. I'm strictly looking for these vertical lines right now. So, right, so this one's different. This one is avoiding this y-axis, but here we do have, there we go, we do have equations for vertical lines. Are they x equals a number or y equals a number? So this would be x equals what? Good job. So if I come back over, this would have been x equals 0. Horizontal vertical lines, that was last year. Because that's, if I asked you, if this was a line that I asked you the equation for, right? You would be x equals 2. Now, big picture, this is the discovery piece we're trying to accomplish today. Highlight x equals 2, and then please highlight the denominator. We'll see, we got to figure it out though. There's some kind of restriction, right? We got to find out what the restriction is. What happens if I plug in or I substitute 2 for x? Interesting. But we don't know yet. Let's try. So we all agree, yes, that the graph is avoiding x equals 2? Okay, let's all try right now, f of 2. So we're going to use this function right here. We're going to use this function right here, and wherever we see x, we're going to plug in a 2. What would I have in the numerator? 2 minus 1 divided by?
2 minus 2.
Is that okay? Let's see. What's 2 minus 1? 1. What's 2 minus 2? 0. Is that okay? No. This, if you tried putting this in your calculator, it would be, oh no, error. Yes. Say that one more time. They are called rational functions because we do have x in the denominator, which means there's something that we're going to have to restrict. Can't divide by 0. Can't divide by 0. Oh no. Sad face. What x value made the denominator 0? X equals 2. X equals 2 made denominator. There you go. That's my restriction. So how do I say x can be anything I want, just not 2? That's now what we have to figure out. How do we write that in math? Anything I want, not 2. I need a single way of writing it. Let me give you a hint. It's a version of the equal sign with a slash through it. Very good. This means x not equal to what? What are we saying x can't be? 2. That's my domain. Negative and positive doesn't matter. That was for the even root function. You can divide by a negative number, right? You can divide by positive numbers. We just can't divide by 0. That says x equals 2 made the denominator 0. Go ahead and look at the next graph. What are we going to highlight?
Line.
Ms. J, 142? It's okay. Hi. Yes. Yes, I will. You're welcome. Bye. So, folks, those of you who are rapping right now, that's why you didn't know how to do the homework. I was waiting for you to fix it yourself, but now I have to say it. Please stop. Pay attention. Focus on this. What two lines are we going to highlight right now?
The x-axis and the x equals.
Well, this x-axis, we're not looking at horizontal values. What vertical values, Jeffrey? Yes. Where are they located? Where is this one located? So what's the equation of that vertical line?
X equals -3.
So this one would be x equals -3.
It's in the middle though.
And what's, right, so halfway between -2 and -4? -3. We have, good job, we have another one. What's the other one? So this one is avoiding two values. Let's see if we can figure out why that is. Interesting. We know the denominator matters, right? So let's highlight our denominator. Well, we know we can't divide by 0. So obviously these values must be connected to that somehow. What if I let x be 3? What's 3 squared? 9 minus 9, 0. What if x is -3? What's -3 squared? Positive 9 minus 9. So how many values have to be excluded here? 2. So how are we going to write our domain? All real numbers, x not equal to -3 and 3. Both of those numbers have to be excluded.
Wait, why you saying it?
Because both of these x values make my denominator 0, and that's not okay. All right, let's summarize. In the bottom here, why did these x values need to be avoided? Why? Because what do they make happen? It makes what 0? Because they make? The homework will be to go online and watch B period's video to finish. I made it through all the way through the practice. I made it through this. Yes. Oh, hold on. Let me clarify that. Look on the inside. Do not do this practice. The homework is the back page. Yes. So I will be putting up this video so you have a full explanation of the homework that we weren't sure about, and B period video. We're going to go as far as we can. In B period, we did this bottom part, and I did all of these practice questions and these notes at the bottom. So tomorrow I will be looking that you have these notes filled out, which means you did go online. You don't have to watch the whole class. Just fast forward to where you see me talk about this, and homework is the back page. But we are going to work till the bell, so we are not done. So why did these x values need to be avoided? Because they make a restriction. They make the denominator. That's supposed to say denominator. Denominator equals 0. And we can't divide by 0. Can't divide by 0. So here is the big strategy. This is our main important strategy. Take denominator. Keep writing an M. Take denominator. It's just one sentence. Denominator. Set equal to 0 and solve. Ms. J, 142. Yes. Yep. Bye. Step 2 is just what our answer is going to be. Hold on. Answer. All real numbers, x not equal to 0. Or, sorry, no, not 0. X not equal to whatever you got. Whatever you get when you solve, all real numbers, x not equal to 0. Homework tonight, so we're crystal clear. Online from B period, I did all of this practice. Look at the screen. 1 through 4, and these big picture notes. I will be checking tomorrow that you went online for this last 10 minutes of class that we did not get to. Fill in the notes. Do not, look at the screen. Do not do the mixed practice. Your homework is on the back page. We're going to catch up. Yep, go online, get those notes. I need to see Rosalina and Shamar. Everybody else, have a nice day.